All right. So you are being recorded right now. Hopefully nobody minds.
Yay.
I don't know that there'll be much tonight, especially. I'm going to go through a little bit of the basics, but it's not going to be super in depth. So this should be relatively informal tonight, just to kind of get us started and make sure everybody's here. Also, just to see who's still enrolled in the class. So I'll treat this as if you guys show up, that you're still enrolled in the class. And if I don't hear from somebody tonight, I can always try to reach out to them again. So anyway, like I was saying, problem with that is with how this is going. Oh, somebody needs to mute my microphone, or mute their microphone. I think it's Josh. Yep. Nope. All right. So figure out. Okay. Yeah. There you go. So you all muted. That works. So unless you're talking, mute your microphones, because otherwise it will echo through if you're playing it on your speakers on your computer, which is why I'm using headphones. Also, they're a better mic than what's on my computer. So, so like I said, because we don't have the lab, we're gonna have to have a little bit of filler work here, but that's not a big deal. Like I said, I'll kind of try to keep it pretty entertaining, and not too. I won't be dragging you guys down with a lot of extra work by any means. I'm taking, maybe like a 30-minute YouTube video that you watch, and then kind of what I was planning is we'd have a forum on the page, and in the forum you could put a question that you had from watching that video, or if I have you reading a paper, you could put a question from the paper, and then I'd like you guys to answer 2 other questions in that forum. So if that makes sense. So like each one of you would write your own question, and then you'd answer 2 other students' questions. And then that way we can kind of encourage a little bit of interaction with that. It's okay actually what I'll have you guys do so that it encourages quick response is try not to duplicate other people's questions. So if you're the first one in, you might get the obvious question. If you're the last person in, you're going to have to think about it a little bit, figure out what your kind of oblique question is going to be. So with that in mind, I think we're just going to start in. This is most of you. Still missing a few people, but we're 15 minutes after, so I'll assume if they're showing up, they're showing up late, and we'll go from there. So let me see here. I can screen share. And I can screen share. Why are you not there? Hold on a second. Sometimes when we start using new stuff, it's a pain in the butt. I need to close some windows so that I can figure out what I'm trying to screen share, I guess. All right. So let me see here. I need to maximize that. Go back here. Cancel out of that. There we go. All right. So let's go up there. Does this show up like it should be for you guys? Like it's an actual presentation? Okay.
Are these going to be on my Laker link?
I can I haven't uploaded it yet, but I can.
Okay.
Yeah. And yeah, I'll try to put everything up there just because, like I said, this trying to, since it's obviously not like meeting in a class,
Yeah.
we'll have to kind of play this a little bit by ear, and you guys can let me know what's working and what's not, and we'll we'll kind of go from there. And like I said, also in the email, it's going to be a little different for both of us, for all of us. So, you guys cut me a little bit of slack in this. I'll cut you guys a lot of slack too, and we'll try to get you out of this class knowing more than you did when you came in, hopefully. So, all right. So we have watershed processes. I'm Morgan Davies. Richard Litz would have been the watershed uh, employee who was teaching the lab part of this class. Unfortunately, like I said, since we don't have the lab, he provided me with a lot of material. He's actually he's been filming some of the stuff too, as far as using the different equipment, so that we can so I can show you his videos of how to use the different equipment. So it's not the same as being able to use it, but at least you get a little bit of pseudo hands-on experience with it. You can see how to deploy some of the things like thermistors and like dissolved oxygen sensors and things along those lines. Things that you might end up using if you got a job, say, with a watershed, or and if you were doing an internship, it'd be really nice to be able to put some of this on your resume. So we'll get into that in a little bit. So basically, study of watershed processes are kind of the transfer of water through throughout a system, and it's a cyclical system. Obviously, all of you have seen something very very basic compared to this, where you basically have evaporation off the ocean or any water body, and it goes up, you get condensation, you get precipitation, and then you get the water that flows back down into the body of water. And what we're looking at is the difference in how geology affects that, how we affect that, and uh, how the climate affects that. So we're going to look into a little bit of that, and basically throughout this whole term, I'm going to have you guys look at some different papers and some different videos. And like one of the videos I'm going to have you watch is from New Orleans, and it's how they manage their subsurface water flow to try to make it so that when they have these big rain events, like what you had with Katrina, where you had these sea swells and things like that, how you can mitigate that problem when you have all of this water moving down the Mississippi and then you have all the water coming in from the ocean. How do you dissipate that water out and around your city? So there's parts of it like that. There's also parts that like what Richard worked on a lot was 10-mile watersheds, and he has a lot of stuff that's very related to that watershed and to that lake system and the effects that we've had on that lake system and the effects that you know our grandparents possibly had on that system, that we're still seeing some of the sediment flow, some of the incised streams leading into it, how that all changes how a system works and how it affects stuff, and you have this kind of ripple effect that goes through. So we'll look at that as well, and then like I said, we'll also look at the geology of just basically how does the underlying structure in an area affect what your watershed system looks like. So are you in a place that's going to get a lot of flash floods, or do you have soil that can absorb and hold a lot of water and release it over time? Or are you sitting on basically bedrock or sand on top of it? You hit a lot of water at one time and it all just goes away really quick. So we'll look at that as well a little bit. And what I'll try to do is I'll try to bring in a lot of examples from outside of the area, but I also want to tie in a bit of this into what we currently see here, because even if we can't go out in the field right now, these are things that maybe you will have noticed in the past while out hiking around or whatever in the L8, or you will give you something to think about when you're hopefully out of, can go out and wander around this summer. So I don't think it's going to be so bad. We can't go out and wander around this summer, hopefully. So The other part of this, so the first part obviously is the education part of it. The other part of this that I want to do with you guys, and you can tell me if this is something you're interested in or not, is I would like to look at what the different jobs are that are coming available. We can kind of go on to maybe do a day where we look on Texas A&M job board. We look at some jobs that are related to this, maybe some internships, things like that. Look at what their requirements are, and try to figure out that you guys coming out of school, how do you apply for these jobs? What do you need to put on your resume? And what's going to kind of give you a leg up? So we're going to look at a little bit of that, because originally the way that Richard planned this class when he was teaching at Tasha is he wanted a class that you guys could come out of this and you could say, all right, I've used an electrofisher, I've used thermistors, I know maybe it was just for a day, but you have some experience with them. And you can put that on your resume and that would help you get a job. Unfortunately, like I said, we can't do that right now. So I kind of want to go over it in maybe a different way, where at least you're familiar with them when you're talking about them, say in an interview. You can speak in a way that shows you at least have some understanding of how they work, even if you haven't necessarily used them directly. So with that in mind, I might have you guys, as part of your assignment too, submit a resume to me, say for, it doesn't even have to be for a specific job, but we can look at what your resumes look like, and we can work a little bit on how to massage them and make them fit a little bit better for, say, wildlife or watershed type jobs. If that's something you guys are interested in. Like I said, this is, to me, kind of for you guys coming out of a class like this, your main goal should be, how am I gonna get a job in this field? If that's what your goals are in the end. So you might even just be looking at getting into school, but having a summertime job where you're doing this stuff is going to help you out when you go to apply for different programs in schools too. So with that in mind, getting a job in this field, as you guys all probably know, since you're in school right now, unless you get incredibly lucky or somebody, you pretty much need a degree now. The ideal of a summertime job that you're going to get experience in without a degree is getting harder and harder to find, especially with what the job market just currently did. There's going to be a lot of competition. So, that being said, once jobs open back up and stuff starts working again like it should, a lot of those jobs are going to get soaked up, but there's still going to be a lot of competition. So having this degree, and I think you guys all should be getting ready to graduate, right? Is that correct? I only see one of you, so nodding heads only works with Matthew. So, but yeah, Victoria, are you unmuted? Are you?
Yeah, I'm planning on graduating this year with 3
Okay.
associate degrees.
Okay.
Yeah.
So with that in mind, you guys are already kind of past that step. Now, that being said, getting higher degrees helps even more with that. So there's the opening the doors, and then there's moving up. So something to keep in mind with that as well too. So the other part of this is really important, and this is kind of hard, is that you need the degree to get the experience. But once you start getting your experience through either internships with Watershed or summer jobs or volunteering, which is kind of hard to do because we all have to make a little bit of money to live too. Once you start doing these things, you can get experience with some of these tools, even if we can't teach them in the class. So they are always looking for volunteers, say at the Morgan Creek Hatchery, when they're working up fish in the fall and doing things like that. And some of that is you'll go out there for a day and you'll basically learn everything that you were going to learn in that day. I don't know that in some cases it might not be worth it to get, say, an internship there, depending on what they're going to teach you. So you want to look at those things too. So it's like, if it's this a job where I'm going to basically max out my experience gain in a few days, or is it something where I'm going to be learning new stuff throughout the whole summer, which is really nice to know. So, and then here, school, unfortunately, we don't get the practical experience. But like I said, if we do some of the videos, we talk about some things, you guys can ask me questions. I've used almost all of this equipment. What I haven't used, Richard obviously has. So if you guys have specific questions about things, we can reach out to Richard. There might even be a day that we have him come in and do this with us. And so you can ask him questions directly. But that will help at least a little bit when you're talking about the equipment that you might be using for a job. And this is one from Richard, but this is true. If you can get out and you can meet people by volunteering or by doing internships, it's really helpful. And then this is the last bit, and this one you can do while we're stuck at home, is get to know the specific software. So, Excel might seem like just a spreadsheet program, but there's some pretty powerful parts that you can learn with Excel. And if you can learn how to use not just Excel, but I would really try to learn how to use Access as well. Access is if you can write the code for Access and you can start manipulating the database with that, that's a much more powerful program than Excel. So, and a lot of programs use that as their main program for doing their statistical analysis. Even though there's more robust and perhaps better analysis programs out there, Access is kind of the most widely used one. So it's worth it to take a class on that if you can. If you can't find a class, do something like Skillshare or something along those lines where you can do some online classes and just get proficient in it. And then a little plug to me, take your GIS classes. Sorry guys that I didn't get a springtime GIS class. It just kind of never panned out with everything. It'll probably be here next year, but sorry it wasn't here this year. And then study for your interview. Look at what your job is about and kind of do a little bit of research. Say if you're getting a job looking at spawning salmon on the Oregon coast, probably doesn't hurt to do a little bit of research about which salmon spawn on the Oregon coast, things like that. So that when you get asked specific questions, you at least have an idea of what you're talking about. All right. So from there, and like I said, this is a little scattered tonight because this is kind of the overview of what I want to look at when we're teaching this class. So from there, this is Richard's baby from above. So this is the 10-mile lake watershed. You can see that there's multiple lakes throughout the whole watershed, different arms of it that all come together kind of into one system where you have 10-Mile Creek running here, and you have Eel Creek that runs into it that joins in these other systems into the 10-Mile Creek system. Why this one is kind of an interesting system to look at is even though this is a relatively small system, I mean, you're under 100 square miles, this system used to bring back close to 200,000 adult salmon every year. So if you think about that, that's almost what the entire coast brings back now. And that's out of this little tiny system would bring back that many adult salmon. So it was a massive producer. Now a good year is if we can bring back something in the 20,000 fish. And it's, that's considered a pretty good year out of there. So obviously things have happened to the system that aren't good if you're using salmonids as your indicator for health of the system, which is on the Oregon coast, not a bad indicator for a health of a system. If salmon are coming back and spawning in that system and they're doing it in historic type numbers without any sort of hatchery to bolster that number, you probably have a system that's still pretty healthy. So with that in mind, even with this system not producing a tenth of what it used to, it still is a system that when other places like the Coos or the Coquille struggle, you'll get strays out of the 10-mile lake system that will help repopulate those areas. So 10 Mile and then Siltcoos and Taconich, both of those systems are big producers for fish, for coho, namely. So, which is why it's it's kind of a good one to do. Plus, it's really right in our back door. So, I mean, you can just go right, once they let us travel around and explore a little bit more, you can go right up 101 and there it is. And you can go out and you can see some of these arms and you can get back into some of these areas. Now, granted, a lot of this is private land, but there's still road access where you can drive back in and you can see what these arms look like now after a big rain event and what they look like during the summer. So you can also see that it is a lot of a checkerboard around it. You have a little bit of Elliott that borders up on some of the fingers. You have a lot of industrial forest land, and you have a lot of agriculture. And then you also have private residential, which all of these things affect how the system works. So the two biggest problems that you have in the 10-mile system are invasive weeds. So I'm going to touch my face, but I'm at home, so I can do that. Anyway, this is part of why I'm at home. I'm not feeling great right now. So we have invasive weeds that are kind of choking out a lot of the areas. A lot of these, just introduced through, some of them were people putting them in because they thought they looked pretty next to their docks. Some of it was coming in on other boats, people's waders, stuff along those lines. There's lots of ways that you can get weeds that are introduced into an area. In this case, a lot of this is reed canary grass along the edge. The Army Corps of planted reed canary grass all over the place as a bank stabilizer. So much so that they don't actually even know where reed canary grass is native to now because it's so pervasive across the U.S. So it's pretty much any stream system that you see with big tall grass is going to be reed canary grass. And then the other problem they have there is algae blooms. So I don't know if you guys follow along, but occasionally you'll have a thing where they'll say there's blue-green algae blooms and you can't go swim in different parts of the lake. Blue-green algae creates a toxin that's incredibly horrible for a lot of living things. But just algae in general can cause some problems, especially when you have these big blooms, in that it takes a lot of the oxygen out of the system. And when you have the oxygen reduction in the system, obviously that's not great for things that need oxygen to live. So the three main kind of concerns or causes of that is we have a lot of nitrogen buildup, we have a lot of phosphorus buildup, and then we have a lot of sediment. And all three of those things really kind of play into that. So nitrogen cycle, you have breakdown of organic material. It gets pushed into the system through water and leaches out into these lakes. So you can get nitrogen from a lot of different sources. Some of it we are actually putting in intentionally to grow plants. So we have fertilizers, you have animal waste, and you have plant matter. Some of that animal waste can be increased through cattle, which cattle taste really, really good, but they're kind of bad as far as the amount that they eat and the amount that they poop. Anybody who's ever been around a lot of cattle will know that they're not really like horses. They don't do a great job of using their biomass. Puppies. It doesn't seem like a big deal, but if you're actually around big cities where people go out and walk their dogs and not picking up the poop, a lot of times that's in places where you get really good runoff because it's a hardscape. And so you get a big nitrogen push from places where there are a lot of dogs. It's weird as that sounds. And then little kids. And Richard put these in there. I'm not responsible for the pictures of naked little boys, so I'm not going to go to jail. Uh, anyway, all those things are a problem. And then you have phosphorus. Phosphorus also, we get it from fertilizer because a nitrogen phosphorus mix is a lot of times what we put um, into our fertilizer. We don't have much for phosphate mining here, so this isn't a big part of it. But we do have a lot of animal waste. And if you have phosphate in your rocks, you get a erosion from that phosphate in your rocks and you go out. I don't think the sandstone we have here has a lot of phosphate in it either. So most of the excess phosphate that we're getting into our system is from either fertilizing for crops or animal waste or people waste. Because like I said, in around 10 Mile, there's a lot of private land that's like private recreational or private cabin land. And a lot of those leach systems that they have set up for their bathrooms aren't up to what today's standards would be. So you get a lot of leaching from their drain systems into the lake as well. As nasty as that sounds, it's a high contributor for your phosphate and your nitrogen into your systems. So, and then the third thing is sediment. So the sediment, obviously, we're kind of in an actively eroding system anyway. So back in the day, say pre-European settlement, you would still have some sediment load in your big flood systems, but probably not as much. Well, definitely not as much. That doesn't even need a probably not as much. Um, the way we logged in the past and the way that we still log nowadays, combined with the channelization of the stream banks along the edges to increase land for grazing and for crop production, and also road production. A lot of the things that we do exacerbate this problem. And you can see this is a relatively clean day after a storm. And then if you've ever been out on any of these systems after it rained, they're just chock full of mud. And part of the problem with that is, say, like the lake system where you have a lot of inflow of water, and then it kind of pinches down and your outflow is kind of restricted through the 10 Mile river or 10 Mile Creek. So you have all this water coming in at high speed. It's carrying in all of the sediment, and then it slows down when it spreads out into the lake. And when that happens, you have a lot of the sediment drops out into the lake and then doesn't get transferred further out into the ocean. So the lake systems are actually getting shallower and shallower. They're filling in basically with mud. And all of that brings phosphates and nitrogens and everything down into that mud as well. And it kind of knocks down some of your oxygen that's in the water at the same time. So you have this whole problem of your lakes getting shallower. They're also getting a lot more nitrogen and phosphate into them. So they're getting warmer because they're shallower and they have more nutrients in them. So you get these big algae blooms. So this is kind of a slightly childish, but you get what you get when you look searching on the internet of what a system does when it's when it's got a nice buffer area and you're not dumping a bunch of sediment in versus what it does when it's sitting on agriculture and industry. This is obviously using industry as like a city, but industry in other ways. And like I said, this isn't an anti-industry, anti-agriculture class. There's ways that we can do things correctly that can mitigate for a lot of these problems. A lot of times it's not the cheapest way to do stuff, but it can be done. So this is, what we'll look at in this class is not, hey, we need to get rid of all the logging and all the farming. Because like I said, I like to build stuff out of lumber, and cows taste really, really good. So, don't want to get rid of them. So, but what you can do is we'll look at ways that we can mitigate some of this stuff. Anyway, so there's this whole process. We're going to talk about this a little bit. And then the other thing I want to talk to you guys about, and this kind of ties in more not with what Richard does, but with what I do during the summer, is I want to show you how the geology of an area may affect what your streams are doing. So what we're looking at here is the Crooked River. It runs into Prineville here. And if you zoom in on some different areas, we can see how the geology of this area, and this area is a really good area to look at this because you have this high kind of plateau area that goes out into relatively wide valley areas. So we're going to zoom in a little bit here and zoom in some more. And right here, we got these two plateaus that kind of pinch the river in and basically force the river to follow this path. So all this river can do in this area, minus something like the Missoula flood opening up, which obviously isn't going to happen because we're not living in a glaciated era anymore. All this river can do is basically what the Grand Canyon's done, is just eat deeper and deeper and deeper into the ground. It can't move left and right. So this is what that system looks like here. So we have this narrow, pinched in, constrained valley. And this valley will basically look like this, 1,000 years from now, 100,000 years from now. It'll be deeper, but it will look like this. But if we move a little bit further down the valley, we can see where that whole process changes a little bit. And instead you have these wider valleys with your edges are a lot further out. And you can see that instead of being just a straight line of a river, you kind of have this sinuosity in there. And that affects how a system works. It changes the velocity of the water. You get sediment dropout. You get these big flat valleys because you can imagine at some point in time, this little curve of the river was over here, and then this one was over here, and it's worked its way back and forth, and it flattens these whole areas out, and it adds a ton of nutrients to these areas. That's why they're really good for growing stuff. It's also why they're really good fish habitat too, because you get a lot of small gravel in here, you get a lot of spawning, you get a lot of pools and little oxbow lakes and things like that. So you can see that in here. And this isn't even really, I mean, I think this is probably hillshade LiDAR, but you can see some of the old creek paths and the river paths in here, just in the landscape. And if you pull up an even better LiDAR of a system like this, you'll see this really well, where you have this system that's just kind of working its way around, and it creates a lot of complexity to how that river works. And that's really important when you look at healthy river systems. And it's part of the problem with what's gone wrong with 10 Mile is if you look at all the arms of 10 Mile, they all used to look like this. And now, for the most part, a lot of them is a single creek that comes out. It tucks up right next to the road or to the hillside, and it runs the full length of the hillside. And you just have this little essential short creek, where in the past you had miles and miles of this sinuosity across the valley, where you had spawning habitat and you had rearing habitat, and you had a chance for some of that erosion and sediment that you had coming out of the narrow valleys where it's running fast because the mountains are forcing it to run fast. Now, instead of slowing down in these streams and dropping some of the sediment, they're basically still high velocity systems until they get out to the lake. So you get a lot of that sediment still pushed further and further out into the lake, where in the past you would actually get that sediment and nutrients would be dropping out in these fields, which is why they grow things so well. So you can look at kind of some differences too here, where before we had that really tight valley, and this is that same river system. This is just downstream a little bit. Here it's opening it up, and it's able to meander and spread out a little bit. And then further down, you have another tight valley where everything kind of closes back in again. And so you get this dropout of nutrients up in this valley. You get velocity, and then coming out of there, you have a system that looks a little like this, a little cleaner, a little bit shallower, and some smaller habitat. Even though it's still kind of constrained, it can move back and forth a little bit inside of there. So that's kind of what I work on in the summertime. Um, Obviously, during the winter time, I do some different work. Right now, we're doing steelhead spawning surveys. Uh, a little bit of lamprey work. We do some float surveys, some big water work. So any of that, if you guys wanted to ask me about that part of it, during the summer, I also electrofish a lot. So I have experience working with electrofishers. We snorkel streams. We do fish identification and fish counts. I work on the screw traps and the adult traps. So any sort of stuff like that that you guys want to ask me about, that you're interested in, we can tie that into this class. Because like I said, right now this class is a little bit broken from what it was. So what I would really like to do is be able to provide you guys with some experience if we can. I don't think we're going to probably get, right now they're not planning on having any of the class kind of come back together. But I can put you in touch with people for, summer internships, like things like that. I know people who work at like for Kuzwa, and obviously Richard works for the 10 Mile and for the tribe. So we might, some of this might extend not officially as a class into the summer, but it might extend a little bit as a class into the summer. And that if we can get you guys some work working for some of these watersheds, we'll do our best to do that. But in the meantime, if you have questions about stuff that we have used or do use in the field right now, by all means, we'll open the class up that way too. If you guys are interested in electrofishing, I can find you some more videos on that. I can get a hold of one. I can actually go out and film myself electrofishing, which obviously not as useful, but you can see some of the techniques and things like that. So, for right now, I think we're getting close to the hour that I promised. Do you guys have any questions just right now about, what the class is going to look like, or, just other questions along those lines?
No. I don't have
Okay.
any questions.
Could you talk about the forum thing again, like you did at the beginning, about post questions?
Yeah, sure. So basically what I'll do is in the next day or so, I'll find either a paper that I like or a video that I think is useful, and I'll post it up onto the forum, and I'll let you guys know. I'll send you out an email to let you know that I'm posting that. And then I'll have you watch it or read it, depending on what it is. And then from there, if you can kind of think of a question that you have, something that it brought up, or that's a tangent to that video or paper, post your question. And then when everybody's kind of posted their questions, so I want you to do that relatively quickly. And then when everybody's posted their questions, if you can go and answer 2 questions that somebody else asked. Though we have a pretty small class, so for right now, let's just answer 1 question that somebody else asked. So you'll have your question, you'll have 1 answer. And then we'll go through, and then the next week we can go through all the questions and the answers, and we can talk about, whether or not that answer works for that question. Everybody's questions might not get answered. We can kind of go through it, and we'll look. Basically, what I'm trying to encourage is just a little bit of extra interaction between you guys.
Is that going to be like a once a week thing or twice a week? How often is that going to be?
At the most once a week. So yeah, it would just be the once a week, and maybe not every week, depending on because like you guys are going to have to be doing all your work online, and I get that that's different than how you normally would do this stuff. So I kind of want to figure out what your guys' workload's looking like, and so I'm not overwhelming you as well. But kind of, so like I said, we're gonna play this a little bit like by ear. See how swamped you guys get with other stuff, and we'll kind of go from there. But I think that should be, like I said, I'm not gonna have you watching hour-long videos or anything like that. It should be relatively quick and short, and but try to find stuff that's interesting. And I don't need you to be analyzing, massively analyzing other people's papers. I will have you read some scientific papers. I do realize that some of them are a little dry. I will try to find stuff that's interesting and could be pertinent to what you're doing here. I've read a few in the past that looked at like insect communities and leaf litter, things like that doesn't sound super exciting, but it's actually a little interesting on like how insect communities react to the different types of trees that are in riparian areas and things along those lines. So that it looks at riparian areas not just as shade providers, but actually do broadleaf maples perform better than alders or cedars or things like that. So I don't know. We'll find some different work like that. Stuff that like I said, when you go to apply for a job, it might be something that comes up as a tangent to what you're applying for, but if you can speak intelligently about it, it's going to help you get that job. So, other questions? Nope.
Actually, can you hear me?
Yeah.
So, is there any time that would work earlier? Because I'm taking 2 lectures at this moment, and it is tough.
So you were muted when we were talking about that.
Yeah.
But when do you get done with the class that you're not mine, but the class you're currently listening to as well?
That class goes from 6 to 9.
6 to 9. Well,
and
damn.
Only on Mondays too.
Only on Mondays. Okay, so that kind of cuts into our idea of 7:30 for tonight. Victoria, you said Wednesdays work for you. Is there any other day that works for you?
Fridays.
Wednesdays
I don't have any
Fridays.
classes on Wednesday or Fridays.
That Monday class is my only class. So I'm only class with a lecture, so I can do any other time.
Could we do earlier today? Like, could we do like 4 or 5?
So I work until 5. And since I'm out in the field, that I can't guarantee that I'll be back at 5. Which is why I was trying to do a little bit later on into the day. Obviously I'm not going to have you guys meet after 9. That'd be ridiculous. Fridays, it's not ideal, but if that works for you guys. Ethan, you there still?
Yeah, that works to me. I get off at 4, so anytime after that.
Okay. Fridays, I actually typically am not scheduled to work, so I could go a little earlier. We could do, say, Fridays at 5, if that works for everybody.
Yeah, that's fine for me.
Yeah,
okay.
That works.
So let's plan that tentatively for now.
Do you want to do this Friday too?
I don't think so. What I'll do is I'll post some stuff. If you guys have some questions about how that whole forum process is going to work, we could meet for a short period on Friday just to discuss that a little bit more. But let's kind of play that by ear. If it seems like people are interested in that, we'll run a class on Friday. If everybody's feeling good about how things are going, we can just wait until the following Friday. Does that work for you guys?
Yeah, that works.
Okay. So tentatively, we're looking at next Friday at 5 o'clock. All right.
Sounds good to me.
Sounds good.
Guys have any other questions or suggestions for the class? Like I said, we're trying to make this so that it works for you guys, and unfortunately, it's not what it was, which I think is the better design. Nope. All right. Kobe, I did record this, so I will figure out how I'm supposed to post it. I think what they're saying is we post them as YouTube videos and then send you guys a link. So
Okay.
I'll go through and figure out how the hell to do that. So
Okay. Thank you. I appreciate it.
Yep, no problem. And I will post up the PowerPoint that I presented as well.
All right.
It's mainly a lot of pretty pictures, but you guys might be able to use that a little bit too in the future. So I'll put that up onto the that will just be on Laker Link. So that's easy for me to post up. But the video I'll have to figure out because it's going to be, I don't know, hour-long videos. It's a decent sized file. So but I'll figure that all out. I'll have that up in the next day or so, and we'll go from there. So, all right, everybody. If as always, if you need to get a hold of me, you can email me, you can call me, you can send me a text message. Doesn't really matter. That first email that I sent out to you guys should have both my email addresses on it as well as my phone number. So, however you need to get a hold of me, I'm fine with it. All right. You guys have a good evening.
All right.
Bye.
You too.
Thanks.
Yep.
No, just say you're welcome.